Taraj, your chemistry mentor, welcoming you for an important session in solid state. In this session, let me teach you an easy way to learn and the trick to recall the 7 crystal systems from which you can expect sure questions for NEET and JEE. So before starting to learn the 7 crystal type, first you should know the 6 parameters involved in an unit cell, because only based on those 6 parameters we have 7 crystals. Okay, this is the unit cell, and let me show you the 6 parameters. Actually, out of 6 parameters, 3 are axial distances and 3 are axial angles. Already in my previous videos, I have explained about this axial distance and axial angles, but you should know, you should have an idea about this. Only then it's possible to learn the 7 crystal systems. Okay, so what do you mean by axial distance? See, this is the unit cell, and these are the edges, right? These are the edges, right? So the relative lengths of these 3 edges are called as the axial distances. So this is one mean this is one axial distance, this is another axial distance, and let this one. So let me give the naming here, and let this be the 1 and 1, okay, and here. Okay. So this is A, let this be A, and let this be B, and let this be C. Okay. So this A, comma B, comma C, and these 3 are the axial distances. Okay. First 3 parameters. And the next 3 are the axial angles, that is alpha, beta, and gamma. So these are the angles between the 3 edges. Okay, these are the angles between the 3 edges A, B, C. Okay, so where this alpha, will have this alpha. See, in different books, the different parameters will be given differently. Okay, but it is very specific that this alpha is the angle between B and C. Okay, it is the angle between B and C. So you should be very careful. Okay, it is B and C, and the beta angle is between A and C. Okay, it is between A and C, right? So angle between A and C is beta. Understood, students? And angle between A and B is gamma. Understood? So angle between A and B is gamma, angle between A and C is beta, and angle between C and B is alpha. So you should not confuse these angles, okay, between the axial distances, because if you get confused, then automatically the tabular column in which we are going to place all these 7 crystals will be getting disturbed. Angles between these axial distances, okay. Now you know what are axial distances and axial angles. Now I shall help you to learn the 7 crystal systems by using mnemonics, okay, so that you can easily remember them. So I have placed all all the 7 crystals in a tabular column where we are having axial distances, axial angles, and examples. Okay, easily. Okay, I have fixed some mnemonics for the 7 crystal systems. Okay, carry the oranges, carry the oranges to help Maggie teacher, to help Maggie teacher. Okay, so this is the mnemonics. Okay, carry the oranges to help Maggie teacher. Okay, so let me fix the letters now. Carry, C from carry, T from the, oranges O, T from to, H from help, M from Maggie, and T from teacher. Okay, so I have here we have chosen all the letters, but C here stands for cubic. Okay, C stands for cubic, T from the stands for tetragonal, O stands for orthorhombic, T here stands for trigonal. This trigonal crystal type is otherwise called as rhombohedral. Okay, and H stands for hexagonal, M stands for monoclinic, and T stands for triclinic. So why I am giving this mnemonics is, see, if you are having this mnemonics fixed, it is possible to write the crystals in order like this, so that you won't get confused. See here, it is a must that you should write the all the crystal types in an order so that we can easily memorize the axial distances and axial angles and also the examples. Understood, students? So carry the oranges to help Maggie teacher is the mnemonic which I have framed or fixed to learn these 7 crystal types. Okay. So now let us see one by one. First, let us learn how to write the axial distances. So first one comes cubic, tetragonal, orthorhombic, trigonal, hexagonal, monoclinic, triclinic. Carry the oranges to help Maggie teacher. Understood, students? Now we shall see the parameters. So first let us see the axial distances. First, how to learn? See, for the first cubic system, all the axial angles are equal. A is equal to B is equal to C. Okay. Now for the tetragonal, A is equal to B, but it is not equal to C. Okay. And the next one, orthorhombic, is A, it's not equal to B, and it's also not equal to C. Understood? See here all everything is equal. Here the last one is not equal, and here all the 3 are unequal. Okay. Now how to write here? See, these 3 things should be repeated again for the trigonal, hexagonal and monoclinic for the axial distance. So the same thing we are going to repeat. So that here we can write as A is equal to B is equal to C. Okay. And next we are going to repeat this one here. Okay. So for hexagonal, A is equal to B, which is not equal to C. Okay. And let us go for the third one. Third one here, that is monoclinic. The same thing which is written for the third one we are going to repeat. Okay. So A, it's not equal to B, and this is not equal to C. Understood, students? Okay. Now the last one. The last one comes. Here we are going to repeat the same thing. Okay. Here we are going to repeat the same. But anyways, the last triclinic, let me deal little later after starting with the axial angles. After writing here with the axial angles, let me write for the triclinic. Okay. So now we have your, you know how to write the axial distances for these different one. For the cubic, everything is equal. For tetragonal, the last one is unequal. For orthorhombic, all are unequal. Now for trigonal, hexagonal and monoclinic, you have repeated the same thing. Okay. Now we shall see how to write the axial angle, how easy it is. See we should follow this one. Alpha is equal to beta is equal to gamma is equal to 90 degrees. Understood? Then same thing is repeated for the tetragonal also. Alpha is equal to beta is equal to gamma is equal to 90 degrees. Okay. And see the third one, again it's the same. Alpha is equal to beta is equal to gamma is equal to 90 degrees. Okay. So now it's easy, right? So this is easy to write. We have finished. And here also the angles almost is the same. Almost no. Everything is the same. Alpha is equal to beta is equal to gamma is equal to 90 degree. But here the axial distance is different, but the angle is the same. Here the axial distance is completely different, but the angle is the same. Okay. Now we have written now. So now we shall go for the last one. Okay. Triclinic. How to remember easily. See here everything is equal. Now we are moving to the last one. Okay. Triclinic. Alpha is not equal to beta, which is not equal to gamma. Understood? Alpha is not equal to beta is not equal to gamma. Understood? It's easy to remember, is it not? Here also the same thing. Everything is unequal. A is not equal to B. B is not equal to C. Okay. Now check here, students. In triclinic, neither axial distance nor the axial angles are equal. Okay. Both. Axial distance is unequal. Axial angle is also unequal. So this triclinic is an example for the most unsymmetrical crystal structure. So which is the most unsymmetrical? Which is the most unsymmetrical? Most unsymmetrical crystal is triclinic. Okay, the most unsymmetrical crystal is triclinic. And which is the most symmetrical? Most symmetrical, students, most symmetrical structure. Which crystal is having the most symmetrical? Check and tell. See here, the most symmetrical structure is the primitive structure, that is the simple cubic. See here, all the axial distances as well as the axial angles are the same. Is it not? So cubic. So the cubic system is most symmetrical. Understood, students? Okay, now let us move on to the rest of the things. What is the angle here? Okay. So next we should move on to the trigonal. How it is? Say in trigonal, it is simple. It is alpha is equal to beta, okay, and it is equal to gamma, which is not equal to 90 degrees. This is not, the last one is not equal to 90 degrees, okay. So alpha equal to beta is equal to gamma is not equal to 90 degrees. Understood, students? And next we shall go for the hexagonal. Okay, next we shall write the hexagonal. In hexagonal, alpha is equal to beta is equal to 90 degrees. Okay, but gamma, gamma is equal to 120. Gamma is equal to 120 degree. Understood? See, alpha is equal to beta is equal to 90 degrees, but gamma is not equal to 90 degree, but rather it is equal to 120 degree. Now the last one, that is monoclinic. It is very easy. See, alpha is equal to gamma is equal to 90 degrees here, but the beta is equal to 120. Understood? So now this is easy to understand. Okay. So all the three angles are equal to 90 degree in the first three sets, and in the last one everything is unequal. And in trigonal alone it is different. Alpha is equal to beta is equal to gamma, which is not equal to 90 degrees. But in hexagonal, alpha is equal to beta is equal to 90 degrees, whereas gamma is equal to 120 degrees. But the next one, monoclinic, alpha is equal to gamma is equal to 90 degrees, but beta is equal to 120 degrees. Understood, students? But some logic you should follow so that it is easy to mug up. Okay, because we can expect more number of questions in definite questions in NEET and JEE in the case of axial distances and axial angles. Which crystal is more unsymmetric or which crystal is more symmetric, like that they can ask, or give the axial distances or axial angles in orthorhombic, like that they can ask. Okay, anything, any type of question is possible, right? Now we shall move on to the examples for these things. Okay, the first one is for the cubic. NaCl is an example. KCl. Okay, then zinc blends. What is zinc blend? It is the zinc sulfide. Then diamond. Okay, diamond is an example, main example. Then copper. Okay, copper. So they can ask questions like copper belongs to which type of crystal type, crystal system. Okay, or what is the angle in a copper system? Okay, like that the question can be can come, right. The next one is tetragonal. What are the examples? See, I'm giving a few examples here. So it's up to you, students, to mug it up. But it's depending upon your memorizing power. Okay. Then TiO2. But it's better to have a what to say, a clear-cut knowledge about this tabular column. This tabular column is very important. Okay. For orthorhombic, it is rhombic sulfur. For orthorhombic, it is a rhombic sulfurs. Rhombic sulfur is an example for this orthorhombic. And then potassium nitrate, KNO3, okay, KNO3, and then a barium sulfate. Barium sulfate is an example of this type, and then potassium sulfate, K2SO4. So these are all examples for orthorhombic, okay. Next comes trigonal. The trigonal is otherwise called as rhombohedral. So under trigonal, we have calcite. What is calcite? Calcite is nothing but calcium carbonate, is it not? So calcite belong to this. And then cinnabar. Cinnabar. What is cinnabar? Cinnabar is nothing but HGS. What is that? Is HGS. Okay, HGS is otherwise called as cinnabar. And then in some of the questions they have asked potassium permanganate. Okay, potassium permanganate comes under trigonal structure. Okay, and then the next one is hexagonal. Under hexagonal we have examples like graphite. Okay, graphite is an example. Then zinc oxide, ZnO, zinc oxide, and then cadmium sulfide. Okay, this comes under hexagonal. And for monoclinic, it is monoclinic sulfur. Okay, monoclinic sulfur. Monoclinic sulfur is an example for monoclinic structure. And then one more example, sodium sulfate, Na2SO4, 10H2O. 10H2O is an example of this type. Okay, and the next one is copper sulfate. For triclinic, copper sulfate, pentahydrate. Pentahydrate is an example for triclinic. And then potassium dichromate K2Cr2O7. Okay, K2Cr2O7 and also H3BO3. This is also an example for this triclinic. Okay, students, hope you might have understood, right? So this mnemonic, it helps in having a clear-cut idea. It helps us to memorize this tabular column easily. Okay, CTOTHM. Carry the RHS to help mark it, teacher. Well, fine, students, you might have got an easy method to learn and recall the 7 crystal types. Okay, let me meet you with another important topic in a short period. Until then, it's Dr. Anita Raj signing off from you. Thanks for watching.